Hi guys, this is Glenn with Asylum 7, and we're still looking at Cgda, the new framework we're developing. It's still live on Kickstarter for those of you who haven't seen it yet. I'll leave a link in the video description on YouTube. And I think I'm actually going to post this on the Kickstarter as an update. So those of you on Kickstarter, thank you very much for backing the project, checking it out. I'm going to do a tutorial series on creating a basic game. I've had a lot of questions. People have asked me about the 2D capabilities of Cgda, and I'm not really going to speculate as to why. But yeah, what I've done here is created a new application. I'm going to walk you through it. It's just it's a Pong simulator. It doesn't actually have input or anything just yet, but it's still technically in development, and I'm going to be removing all of this code and starting it from scratch. Is some buggy collision detection and generally some things I want to change. The ball is being rendered as a sprite right now, and the final application I'm actually going to have that as a 3D model of a ball that rotates. But yeah, it's pretty simple, and I've already set up the project here with the content files, and let's go ahead and take a look at those. The first one is the ball, and I've just got a white ellipse with a blend on it for that. In the field, I've just got a straight line through with a watermarked alpha blended Cgda logo. In the overlay right now, I've got just zeros to simulate a scoreboard. The sprite font functionality is not quite finished, but it will be by the time this tutorial reaches its completion, and we'll actually have scores that update via the sprite patch. And finally, we've got the paddle texture. And what we do, I've actually had a few questions about this too. On Windows, I'm including a winmain.cc file, and it's just a little stub that calls main on Windows, and it's conditionally compiled, so Linux users, Mac users, you don't have to worry about that. But again, I'm just creating a game as a new instance of our tutorial class and calling the run method. And let's take a look at the class. So we've got our sprite batch, we've got the ball texture, the field, overlay, and paddle, which I just laid out from the content manager. Then we've got a few position vectors, one for the ball position, one for the first paddle, and one for the second. And again, we just override load content, update, and render. And let's take a look at those. So again, I've got a couple of constants defined for half of the screen width and height, and the application is full screen at 1280 by 720 at 720p. And again, we just set the root directory to content, create a new sprite batch object, and give it a reference to the graphics device. Load in the field as a texture 2D from field.png. Same for the overlay, the ball, and the paddle. Next, we initialize the positions of the ball and the two paddles, and I've got these calculated out here. They're going to be replaced in the final version, and throughout the tutorial you guys will see how I'm deriving all of the calculations there. During the update function, we just check to see if the ball is moving left or right, up or down, and update the position based on the speed, and in this case we're actually moving at 256 pixels per second, so we multiply that times the elapsed time. Then we just check to see if the ball is to the left edge, or if the ball is past the right edge of the left paddle or past the right edge of the left paddle, and this could be a lot clearer. But again, that will be replaced with a couple of rectangle intersections for collision detection. But we just flip the horizontal and vertical directions. And next, we just clamp the position of the ball to make sure that it doesn't go beyond the boundaries of the screen. And we set the paddle positions, again, temporary. This will be replaced by actual AI and a method of player control as well. But we're just setting the position of the paddles to match the position of the ball. Then for the rendering, we clear the screen to this dark gray. And we start up the sprite batch. We begin this batch by sorting sprites by texture. And they are alpha blended, so we use the alpha blend state. Draw the field texture at vector 2.0. And we want this at a full blend, so we use color white for that and the ball. Now the paddles, to add a bit of contrast, we just colored those in yellow and orange. And the ball is drawn at the ball position. Paddles, obviously, at their respective positions. Then we just draw the overlay on top of that. And again, these are batched by texture. And let's just remove the overlay for a moment. And you can see the overlay is missing. Let's put it back. Now, for the time being, the sprite batch is actually using a geometry shader to generate the coordinates on screen. Although that may not be the most optimal way to do it. But again, that's what we're using for now. We're experimenting with geometry and tessellation shaders in Cgda right now, mainly for the purpose of another demo application that I'm doing for a potential backer that emailed me with a question about BSP trees. So, yeah, we'll be updating that. Again, this is not optimized, but it does run rather smoothly. And that's all there is to it for this application. So stay tuned over the next few days and we'll be going through how to actually create this from scratch in Cgda, complete with collision detection, scoring, sprite fonts, and a blend of 2D and 3D. So thanks again for watching, everybody, and continue to spread the word about Cgda on Kickstarter. This has been Glenn with Asylum 7.